Today we will see what are structures. Before that we should know what are arrays. Arrays we have learned before. Arrays are derived data type that are used mainly for storing homogeneous data type. Homogeneous data items means the same data can be stored. Suppose you want to store the name of all the students in the class. What do? You declare a character array. And you can store around 20 names, each of 10 characters. Suppose you want to store their marks. What do? In marks of 20, this will be marks of 0. Similarly, you will have till 19. So marks are of single data type. Names all will be of same data type. Suppose you want to store the marks, name and their roll numbers all together in a single structure or a new data type. You create a structure. A name will be of character, roll number is of integer, mark is of float. So all those are different data types. So it is called as heterogeneous. So structures are user-defined data type that are used to store heterogeneous data items, but they should be related data items. How you can declare a structure? The syntax is struct data item data type 1 variable 1 data type 2 variable 2, or if you want you can have more than one variable of the same data type. Variable 1 is of maybe integer, variable 2 character, v3 and v4 can be float, like that. Close the brace, semicolon. You are declaring a structure student. Struct is the keyword. Student is the structure name. Name is of character, roll number is integer, marks is float. Now there are two ways in which you can declare variables. Either one is along with the definition you are declaring a variable s1, s2 like this. Or if you want, what you can do is in the main function using this keyword struct you can declare the variables. This is one way, that is within the using the keyword struct. The other one is along with the structure definition you are declaring the variables. Now when you are declaring a structure, memory space is not allocated, but when you declare a variable, memory space will be allocated. How many memory space will be allocated for the variable s1? It depends on the details over here. Name 20 bytes, roll number as it is integer 2 bytes, marks as it is float 4 bytes. So total memory allocation of 20 plus 2 plus 4, that is 26 bytes will be allocated each for s1, s2, s3, s4. When you are declaring or defining a structure, memory space is not allocated. When you declare the variables, memory space will be allocated. Hope that is clear. Next is how you can initialize the structure variables. Here we have defined structure student. It is having two variables, name and roll number. Along with the definition, we have declared the variable s1 and you are initializing the values. You will be putting the values within braces. First one is the name. S1 will be assigned, S1's name will be assigned as John. S1's roll number will be assigned as 5. If you want another variable, you are separating it by a comma. S2 equal to name and the roll number. Semicolon. So you are having two variables. This is one way of initializing the variables. Other one is same as like how you are declaring the new variables within the main function using the keyword struct. You can have struct student s3 name roll number. Now how you will access these variables? If you give a printf statement, this for character and this for integer. s3 dot name comma s3 dot roll number. So in s3 dot name you are having Sana, s3 dot roll number you are having 15. So the output over here will be Sana and 15. That is, you are having the dot operator for accessing the variables. How is the memory allocation over here? We will look. For S1, name will be stored as John, 20 space is allocated, and roll number 5, 2. This is for S1. Similarly, S2 you will be having name and roll number. Similarly, S3. You are using the dot operator for accessing. This is called as the dot operator for accessing the members inside the structure. Next, we will see how you can read and print data of a single student. You declare the structure student with variables name and roll number. You are having the main function. You have declared a variable S1. Struct is the keyword, student is the structure name, and S1 is the variable. Enter the name and roll number. S1 dot name. Whatever is entered as the name will be stored in S1 dot name, and roll number will be entered in S1 dot roll number. Similarly, you can print the name and roll number, S1 dot name and S1 dot roll number. You can similarly create around 5 structure variables and read the student's name and roll number of 5 variables. So instead of declaring 5 variables like how you was doing in arrays, you can create an array of structures that we'll see in the next program. This is how you can read and print data of n students. Same way you are declaring the structure with name and roll number. In the main program you have declared struct student s of 10. So you can store the details of 10 students. Printf enter the number of students. You have stored the number of students. How many students you have to enter as n. Enter the name and roll number of students. You are using a loop for iteration. For I equal to 0, I less than n, I plus plus. Printf student, first student. Sorry, I plus 1. That gives you the first student. Scanf percentages percentage d si dot name and ampersand si dot roll number. So the first one becomes s0 dot name, s0 dot roll number. I is incremented 1 less than 5. Print second student. So s1 dot name, s1 dot roll number. Similarly, it is repeated till 5. Suppose n is 5. Now printing the details of n students. For I equal to 0, I less than n, I plus plus. Printf. In between the name and the roll number, you simply put a /t space. And for each next student, you have entered a /n. You will be printing si dot name and si dot roll number. So you have learned how you can declare students, how you can declare a structure, how you can read and print the details of a single student, how you can read and print the details of n students. Hope it is clear.